LWO1 WeatherNet. Liftoff conditions looking pretty good.
The STS is ready for launch.
Ignition. Liftoff.
Falcon 9 has cleared the tower.
Ten, 9, 8,
Side booster ignition.
6, 5, 4, 3, 2, 1.
Good morning, it's Wednesday, March 24th, and you're looking at a live view of Falcon 9 as it awaits its 4:28 a.m. Eastern Time launch from Pad 40 at Cape Canaveral Air Force Station. Hello from SpaceX's headquarters in Hawthorne, California. My name is Andy Tran, and I'm a production supervisor here at SpaceX. You're watching a live view of our webcast, live webcast for our 23rd Starlink mission and our 9th mission of 2021. Starlink is a constellation of satellites that can provide high-speed, low-latency internet all over the globe, particularly in remote areas where connectivity is limited or completely unavailable. Today, roughly half of the world's population, or nearly 3.6 billion people, don't have access to the internet. If you've been following our Starlink's progress, you'll know that Starlink beta service is now available in the United States, Canada, the United Kingdom, Western Germany, and the South Island in New Zealand. As we launch more satellites, install more ground stations, and improve our networking software, data speed, latency, and uptime will all improve dramatically. And with every Starlink launch, we get closer to our goal of nearly global coverage of the populated world. And speaking of goals, at the beginning of March, we completed our third high-altitude flight test of a Starship prototype and are anticipating the next Starship serial number 11 flight test in the days ahead. I'll share some of these highlights a bit later in the webcast. Currently, we're just under 10 minutes from liftoff. All systems are go for an on-time liftoff this morning. Once Falcon 9 lifts off of the ground, our first and second stages will separate about 2.5 minutes into flight. The first stage will then return back to Earth to attempt its sixth landing, this time on our drone ship, Of Course I Still Love You. And while that's happening, our second stage will continue on its journey. In order to get our satellites to the intended orbit today, we have 2 coast phases, and we'll be igniting our Merlin vacuum engine twice, with the deployment of our Starlink satellites around the T+1 hour and 4-minute mark. We're just heading towards that T-minus 9-minute mark. All systems, again, are go for an on-time liftoff this morning. With that, let's take a closer look at the rocket that you see there on screen. This is a live view of Falcon 9, our 2-stage liquid-fueled rocket. It's 70 meters tall, greater than the wingspan of a 747 aircraft. We are flying today's booster for a 6th time. This rocket first flew on the GPS-3 Space Vehicle 3 mission in November of last year, followed by 2 Starlink missions. In 2021, it supported the Turksat 5A mission in January and another Starlink mission in February. The bottom 2/3 of the vehicle is the first stage. You can see the soot markings left over from its previous 5 flights. The first stage's job is to accelerate the vehicle through the Earth's atmosphere into space with the help of 9 Merlin engines at the base of the rocket. And as I mentioned earlier, we are going to be attempting to recover the first stage on the drone ship that you see on screen right now. That drone ship is named Of Course I Still Love You, and if we are successful today, this first stage will be returning for the 6th time. And on top of the first stage is the black carbon fiber inner stage. And then on top of that is the Falcon 9 second stage, which has a single Merlin vacuum or MVac engine. Once the first and second stages separate about 2.5 minutes into the mission, the MVac engine will ignite and carry the Starlink satellites into an elliptical orbit around the Earth. And at the top of the rocket, you'll notice a large nose cone. That's where the stack of Starlink satellites are safely enclosed. The fairing protects the satellites from aerothermal heating, aerodynamic loads, and contamination during ascent. Once we reach the vacuum of space, we will jettison the fairing halves as the second stage continues its journey into orbit. It will be the second flight for today's fairing, and we're going to be attempting to recover each half again in what we refer to as a wet recovery, which just means that we'll be retrieving each from the water. Falcon 9 has been loading propellant since the T-minus 35-minute mark. We use a rocket-grade kerosene known as RP1 for our fuel and super chilled liquid oxygen, or LOX, as our oxidizer to power Falcon 9. Currently, RP1 and LOX are nearly fully loaded on both stages, and LOX will continue to be topped off right until the final minutes of the countdown. The latest weather report is 90% favorable for liftoff, and weather conditions also look good for booster recovery as well. With that, the vehicle, satellites, weather, and range are all looking good for an on-time liftoff just a few minutes from now. If for some reason we don't launch today, we do have a backup opportunity tomorrow at 4 a.m. Eastern. And for those that have been following SpaceX, you know that it's been an exciting time for the development of our Starship launch system. Our Starship spacecraft and Super Heavy rocket, collectively referred to as Starship, are designed to be a fully reusable transportation system that can carry both crew and cargo to Earth orbit, the Moon, Mars, and beyond. On March 3rd, Starship test vehicle known as serial number 10 completed SpaceX's third high-altitude flight test of a Starship prototype from Starbase in Texas. Similar to the high-altitude flight tests of Starship serial numbers 8 and 9, serial number 10 successfully reached its apogee at 10 kilometers with the help of 3 Raptor engines. It then performed a propellant transition to the internal header tanks, which hold the landing propellant, before reorienting itself for re-entry and a controlled aerodynamic descent. The Raptor engines reignited as the vehicle performed the landing flip maneuver immediately before successfully touching down and landing on the pad. Most of the testing at our Starbase Texas location has been focused on the spacecraft, but the team just finished the first Super Heavy booster that you see on screen right now. Known as Booster 1, this vehicle is a production pathfinder. We'll use it to figure out how to build and transport a 70-meter tall stage. All in all, it's been a great couple of weeks for the Starship teams. These test flights and pathfinders are all about developing a transportation system that can help humanity return to the Moon, travel to Mars, and beyond. We are anticipating serial number 11 to take flight in the days ahead, so be sure to check our social media accounts for updates. We are just under 5 minutes from liftoff, and Falcon 9 is now moving into the final stages of the countdown. We're currently waiting for the Transporter Erector, or TE, to retract away from Falcon 9. That is the white painted structure right next to the vehicle. First, the TE clamp arms will open up, and then the Transporter Erector will begin to retract away from the rocket slightly, and you just heard the call out that we are beginning that process. At T0, the hydraulics will pull the TE farther away from Falcon 9 as it lifts off. The Transport Erector has a couple of jobs. It provides liquids, gases, electrical connections to the second stage, as well as air conditioning to the payload fairing. And you can see that the clamp arms are now open at the top of the vehicle, and we should see the Transport Erector begin to retract away to its pre-launch position from Falcon 9. The first and second stages are both nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Super chill liquid oxygen is our propellant oxidizer. That is what's creating those white clouds that you see around Falcon 9. And that's because the warm, humid, ambient air causes the liquid oxygen to turn into gas. First stage should finish prop loading around the T-3 minute mark, and the second stage should finish about a minute later around the T-2 minute mark. At T-60 seconds, Falcon 9 is in startup. This means that the rocket's autonomous internal flight computers have taken over the launch countdown, and just inside of the T-2 second mark, we light the Merlin 1D engines, and we're set for liftoff. The Starlink payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Weather is continuing to look great, and the range has cleared the surrounding ground, water, and airspace, and are also green for launch. For those of you just joining us, what you're seeing on screen right now is a live view of Falcon 9 at Space Launch Complex 40 in Cape Canaveral, Florida. We're just a few minutes away from liftoff. This is the 9th mission for SpaceX in 2021 and the 23rd Starlink mission. And at this stage, the vehicle should be completing second stage LOX loading.
Stage 2 LOX load complete.
And there's the call out. That is the last of propellant loading for Falcon 9. We're continuing to see liquid oxygen being vented from the transport erector lines. This is normal and expected for us at this stage in the countdown.
Ground gas closeouts.
And on screen is a view of the fairing. Inside that fairing are the Starlink satellites that we're going to be sending into orbit today.
Falcon 9's in startup.
We are in startup. This means that the first and second stages are beginning to pressurize for launch. In just a few seconds, we should hear the launch director give the final go for launch.
Falcon 9, Starlink LDs go for launch.
And just over 30 seconds, all systems are a go for launch. Let's listen into terminal count and watch as Falcon 9 takes our 60 Starlinks into orbit.
Vehicle is pitching downrange.
Stage 1 chamber pressure is nominal.
Power into telemetry nominal.
We're just under a minute into flight. Falcon 9 has successfully lifted off from Pad 40 at Cape Canaveral Air Force Station, carrying our Starlink payloads into orbit. In just a few seconds here, we should be
Vehicle is supersonic.
hitting max Q, or maximum aerodynamic pressure.
Vehicle is now experiencing maximum aerodynamic pressure.
And there's the call up for max Q. In about a minute, we have 3 events happening back to back. First up is main engine cutoff, also known as MECO. This is where all 9 M1D engines shut off to slow the vehicle down in preparation for stage separation.
Engine chill has begun.
The second event is stage separation. This is where the first and second stage will separate from one another, with the first stage making its way back to Earth for a landing attempt, while the second stage continues its journey with the third event, Second Engine Start 1, also known as SES-1. This is where the single Merlin vacuum engine on the second stage will light up and propel the second stage along with the Starlink satellites into orbit. Again, that is main engine cutoff, followed by stage separation, then second engine start 1. And the first of those events should be happening in about 20 seconds. Both views on screen right now are of the first stage. The left is from the top of the first stage, and the right is a tracking shot from the ground of Falcon 9.
Main engine cutoff.
Stage separation confirmed.
And we had successful main engine cutoff, stage separation, and you can see on the right-hand side of your screen, the engine on the second stage has successfully started up.
Fairing separation confirmed.
And off come the fairing halves. That call out and the visual confirmation on your screen means that we've had successful fairing deploy. As a reminder, this was the second flight for each of the fairing halves, and we're going to be attempting to recover the fairing halves again via a wet recovery. We are at T plus 3 minutes and 50 seconds into flight. On screen is a view of the Merlin
Both
vacuum
vehicles
engine.
continue to follow nominal trajectories.
The Merlin vacuum engine on the second stage glowing red hot. As the second stage heads towards its drop-off orbit, stage 1 will execute 2 burns in order to make its way back to Earth.
Acquisition of signal, Bermuda.
The first is an entry burn where 3 of the Merlin engines will reignite, and this will help to slow the stage down as it re-enters the upper parts of the atmosphere. The second burn is the landing burn. This is a single engine burn that brings the vehicle speed down rapidly in order to land on the drone ship. We don't currently have views of the first stage right now, but as we approach the landing attempt, hopefully we'll be able to get that view back. The Merlin engines on the first stage are optimized for sea level, and they can achieve 190,000 pounds of thrust during ascent and descent. The Merlin vacuum engine you see on screen is optimized for the vacuum of space.
Both vehicles continue to follow nominal trajectories.
Producing over 220,000 pounds of thrust in a vacuum. That first stage entry burn, again, that's the first of 2 burns, should be happening around the T plus 6 minute and 20 second mark, about a minute from now. The Starlink satellites that are on the opposite side of the second stage, we're going to be putting them in low Earth orbit around 550 kilometers in altitude. Most satellites are in geostationary orbit at an altitude of about 36,000 kilometers. When satellites are farther away from Earth, the round-trip data time between the user and satellite, also known as latency, is much higher, resulting in poor performance for activities such as video calls and online gaming. The Starlink satellites, however, operate at over 60 times closer to Earth than traditional satellites, resulting in a much lower latency.
Stage 1 FTS is saved.
And there's the first stage on the left-hand side of your screen.
Stage 1 entry burn startup.
And we have successful stage 1 entry burn start. This burn's going to last for about 20 seconds.
Stage 1 entry burn shutdown.
And stage 1 entry burn has completed. During that entry burn, you might have noticed that
Both vehicles continue to follow nominal trajectories.
4 hypersonic grid fins have deployed near the top of the first stage. The stage 1 uses nothing but these grid fins for steering as it makes its return back to Earth. They orient the rocket during re-entry and guide the rocket during descent. The next milestone for this mission is our landing of the first stage. That's going to be happening in about 40 seconds, with the entry burn starting around the T plus 8 minute mark. During the entry burn, the first stage landing legs will deploy. We have 4 of them on Falcon 9 first stage, and they're made up of state-of-the-art carbon fiber with aluminum honeycomb. They're placed symmetrically around the base of the rocket and will deploy just prior to landing on our drone ship today.
Stage 1 landing burn startup.
There's a view of our drone ship as Falcon 9 approaches.
Stage 1, landing confirmed.
We didn't quite
Stage
get
2
the
is under
video, but
terminal
we did get
guidance.
confirmation that we did indeed land the first stage. That is the 6th for the. Oh, there's the visual. This is the 6th time for this
Stage 2
booster,
FTS is safed.
and the 78th successful recovery of a Falcon 9 first stage. What a way to start off the mission today. Now we're waiting on second engine cutoff of the second stage, and then shortly after that, we're expecting to hear confirmation of a good orbit.
Seco.
Expected loss of signal, Cape Canaveral.
And we did see the second stage engine
Nominal parking orbit insertion.
shut off, and there is the confirmation we were looking for. Now the second stage is going to coast in this orbit for the next 35 minutes or so. We'll leave you with two things, an animation showing you where we're at in this coast phase, and some space tunes. We'll see you back here around the T plus 44-minute mark for second engine start number 2.
Acquisition of signal, Newfoundland. Expected loss of signal, Bermuda. Expected loss of signal, Newfoundland. Acquisition of signal, Lagoon Hilly. loss of signal at Goon Hilly. Acquisition of signal, Diego Garcia.
Welcome back to the live webcast of SpaceX's 23rd Starlink mission. We had an on-time liftoff at 4:28 a.m. Eastern Time, and today's first stage had a successful sixth flight and recovery. Our second stage is still looking good. You can see it on screen right now, and is on a nominal trajectory, getting ready for second engine start number 2 in just a few seconds. It will be a very short 1-second burn of our MVAC engine. Shortly after the burn, we should be hearing confirmation of a good orbit for the second stage, and then we have another coast phase after that. And there's a view of our second stage. And it does look like we started up our second stage. Now we're going to be waiting for confirmation of second engine cutoff, followed by confirmation of that good orbit. Hopefully we get the video back of our second stage. Until then, we have an animation of where exactly the second stage is at around the Earth. I am getting confirmation that we indeed have a good orbit. We have another coast phase before we deploy our next batch of Starlink satellites into orbit. During this time, the spacecraft will start to spin along its central axis, giving the Starlink satellites the momentum they need to space themselves out over time after they deploy. We'll see you back here at T+1 hour and 3 minutes.
Expected loss of signal due to Russia. Acquisition of signal, Tasmania.
Welcome back once again to SpaceX's 9th mission of 2021. If you're just joining us, a quick recap of today's mission. We had successful liftoff from Cape Canaveral Air Force Station at 4:28 a.m. Eastern. We then had successful stage separation, recovered our first stage for the 6th time on our drone ship, and had 2 successful second stage and back engine startups. We're now coming up on deployment of our stack of Starlink satellites that you can see on screen. Let's listen to the callouts for payload deploy. It should be happening any second now.
Starlink deploy confirmed.
And you can see on screen, you heard the callouts. The satellites are slowly separating from the second stage. Shortly, they will deploy their solar arrays, and over the next few days and weeks, they will distance themselves from each other and use their onboard ion thrusters to make their way to their operational orbit. And that brings our webcast to a close. Thank you to the Range and Federal Aviation Administration for supporting today's mission. And thanks to all of our viewers, as well as all of our customers using our beta service at this time. If you are interested in being part of our beta program, head over to starlink.com and sign up. One last thing to mention before we go. Today marks the 15th anniversary of Falcon 1's first flight, which some of you may recall did not result in a successful flight. But with more than 100 successful flights of Falcon 9 and 78 recoveries of our first stage to date, we've made a lot of progress since then. With that bit of SpaceX history, thank you for joining us and have a great rest of your day.